All right, variables and expressions. Somebody said no, but we're going anyway. So like I said, we're going to try to do 1, 1, and 1, 2 today. So we'll start with 1, 1 because that comes before 1, 2. Tell me what, when you hear the word algebra, I don't know if I should even ask this question, but tell me what you think of when you hear the word algebra. Okay. Solving for an unknown. What is that unknown called? A variable. Or X we use a lot, right? Algebra is really focused a lot on variables. And so a lot of you said just now they're unknowns, they're things. So define variable for me in the best words that you can. X besides just X, what? Exactly. Good job. It's a letter that represents some unknown value. We most commonly use X, but it does not have to be just X. And so we can put numbers with the variable. Maybe I have 3x, right? X here is my variable. And this would be what we call, and maybe I can even do something else. Let me say plus 2. When we have this expression that includes variables, we call it, am I going too fast for y'all? Okay. We call it an algebraic expression, and that just means that it is an expression. Now, y'all know what expression means? Multiply, divide, add, subtract, all of these operations. It doesn't have to include all of them. It can include just one or more than one that are being done within this piece here, right? That's an expression. And it becomes an algebraic expression when you throw a variable in there with it. Does that make sense to everybody? Tell me in words what this is. If you had to tell somebody who'd never seen that before, give that to me in words. But give me like 3 times x, that's right. 3 times, how do you know it's times there? This is the implied operation right here, right? Really important, we don't use x anymore to represent multiplication because once we've hit this point in math, x is used a lot for our variables, so it can be confusing. So there's no operation there which is implied multiplication. So 3 times x, finish it, plus 2. Everybody okay so far? This is just a lot of definitions in this first section that you probably already know, but I'm going to try to take it slow anyway, which I generally try to do, so we make sure we... So don't be scared to tell me to slow down or re-explain something or anything like that, okay? Because I don't ever mind. All right. Tell me this. Algebraic expression, yes or no? Yes. There's operations there, right? And there's a variable. It doesn't matter that the variable is not x, it just matters that there is a variable. All right, let's say I have, let me get one from you. That's a z, by the way. Is that an algebraic expression? Yeah, sure. I got addition, I got division, and I have a variable, so I am an algebraic expression. Now, we said this is the variable, right? Does anybody know what the pieces separated by the plus or minus there in the expression are called? In other words, what I would call the 3 and what I would call the z over 6. Okay, so you're thinking if I had this, yes, 3 would be called a coefficient. But all together, what would the 3x be called? Or what would the z over 6 be called? You know, it starts with a t. Yes. Somebody said it over here. Term. These are terms. Terms are the pieces that make up the algebraic expression. What do you call a term, and I'm really going to test you here, what do you call a term that doesn't have a variable? It is a number, but what else could you call it? Starts with a C. Think. If it doesn't vary and it's always the same, a constant. Good job. See, you were worried and you're getting all the answers. This is a constant term because it has no variable. Everybody good so far? Let's see then. So let me show you another type of term and see if you have seen this before. How about it's an exponent. X cubed. Good job. So what do we call this number here that's being raised to something? The base. That's the base. And the 3 is the or power. That's right. So this is an exponential term, and we will encounter a lot of those. Tell me what this means. What does it mean to raise it to a power like that? What you got? That's exactly right. Good job. This means it's x times x times x. It just tells us how many times we need to multiply it. So we could read this if we put it in words as x to the 3rd power. That's exactly right. And I keep doing this because part of your homework is going to have you write in words or take the words and write the expression. So I want to make sure you can go fluently between them. How about this? Let me give you the words and see if you can write the expression. A number t more than 6. How would you write that as an algebraic expression? But it's a variable, so you can use it. It represents a number.
Oh.
Say again? So how would you write that? How would you write that as an expression using only multiplication, division, addition, subtraction, or exponents? Addition. More than is addition, right? So give me the expression. What would it look like? T plus 6. Easy peasy. That's when y'all are supposed to say, lemon squeezy. I appreciate the high pitch that went with that. How about this one? 10 less than, you have to be careful with the less than ones in the order that you do them. Then the product, what does product mean? Good job. Then the product of 7 and F. What you got? Okay, so you're really close, but you got a little backwards. Think about it like this. If I said that I have $5 less than you, how would you write that? Exactly. You have to be really careful when you start getting into the subtraction with the order, because with addition, the order doesn't matter, right? I can add in any order I want to, but whenever I start subtracting, I have to subtract in the right order. All right, so just some keywords real quick, and I'll be done, and it's almost time to go. I'll give you your homework. Some keywords for some operations. Let's do a little chart. Let's say addition. I'm going to give you some phrases, and I want you to classify where they need to go. Subtraction. Multiplication. What's the other one? Good job. Division. The word product of. Where might that go? Multiplication. Good job. Less than. This pen stops working sometimes. Less. More than. Times. Quotient. How about difference? Sum. Can you think of any more? How about, thank you. How about increased by? Increased by. Addition. What would the subtraction version of that one be? Decreased. All right. Listen to this problem and write an expression for it really quickly, and then I'll give you your homework. We still got 8 minutes. We're good. Mr. Martinez orders 250 keychains printed with his can I go to the next slide? Okay. He orders 250 keychains printed with his athletic team's logo, and he orders 500 pencils printed with his web address. Write an algebraic expression that represents the cost of his order. So how much did he spend on his order? What information are you lacking to know how much he spent? How much each one cost, right? So anytime I don't know something in algebra, I put a what? A variable. So maybe for the keychains, I use the variable. What would make sense for keychains? K, maybe? What would make sense for the pencils? Yeah, right here. So, how do you find out how much he spent on keychains? How many he ordered times what? The variable. How much each one cost. That would tell me how much he spent on keychains. Now you tell me how much he spent on pencils. Times P. And if I want to know the total order of the cost, then add them together. That's exactly right. Pretty easy? All right. So that's kind of the way this book works, is you'll start out really basic with definitions, and then you'll move into some examples, and then you'll get into the word problem application type stuff, which is like the example we just did, okay? Your homework for tonight, so go ahead and write it down. I'll also post it on Classroom, but it's a good idea to write it down now. If I ever forget to post it on Classroom, because I generally do it as soon as y'all leave, but if I forget, just send me a remind message and let me know. We're on page 7 and 8. You're going to do 1 through 10. And then, and these should not take you long. They're fairly easy. 11 through 35 odd. Okay? There's not really much mathematical solving and work that goes with this. These are basically translating words to expressions and expressions to words, okay? So it shouldn't take too long. Make sure on your homework when you come in the good